Hello and welcome to the stream. Let's see. So it's been a while since we've been working on this project here. In terms of creating a chess-like great game from scratch. Let me just remove some of these panels here so I get less distracted. Right. Okay, I have my live chat set up here. I think everything is working properly. Okay, should be. Okay. Um, so um, during the last episode, we implemented the object picking. And by the way, I noticed that the uh, the frame rate really does take a hit whenever we have the uh, debugging layer enabled. So if we disable it and build it without the debug layer, you can see that our FPS almost doubles. We're still nowhere near 1 millisecond of frame time, so performance is still great. And when I disable OBS, everything is way better. So yeah, our application is definitely running pretty fast. Besides that, I also tested out what took or whether rather what affected performance. So yeah. But anyway, let's get back into it. Yeah. So we would like something like some kind of processing of when we click an object, maybe we want to move it. So up here we have the whole click function. Let's do a scope. Let's do the raycast and check against ABBs. Okay, and let's simply move this. Okay. So this is our raycasting device, or what do you call it? So let's just put this in a scope. Materials. Just tidy this up a bit so it gets more readable. Let's see. We have tiles. We can always calculate the amount of tiles by multiplying these two together and then offsetting by 1, and then we will have the tile, or rather the index itself. Okay. Let's see, let's create a game state for the unit here. Let's still set it to belong to our player 0. Let's see, let's do units. And I actually think this should be 0. 2.0 rather. Okay. So we create the objects. Let's see. And we can always update the mesh transform. Okay. So we can do a logic check here. If the index is larger than 0, or rather larger than or equal to 0, and if the index is less than 64, let's try call print clicked a chess tile, else if index greater than or equals 64, clicked a pawn, question mark. Clicked a pawn, chess tile, pawn. Great stuff. And let's set number of chess pieces, chess board fields. Let's see. Board tiles, tile rows, tile columns. And there we go. This should still work. Okay. Chess volumes -0. Let's see. Well, clicked a pawn shouldn't trigger. Let's see. Maybe just, there we go. Maybe it's the comparison here. Yeah. Yeah, I did a comparison between an unsigned int and an int, and yeah, the compiler probably reduces it to something like a binary comparison. Either way, it won't work when comparing different types, because this is below 0 potentially when I click something else than a pawn, and yeah. Anyway, okay. Uh, um, and we can simply calculate our pawn index equals the index minus the number of board tiles, number at index, pawn index, and we pawn index 0 and pawn index 1. Okay. And we want a reset here, reset logic. Okay, so our application game state, selected index, okay. And we update our previous selected index. And we can of course do some processing. So if we and this is the whole updating of the visuals. So if we click a pawn, for instance, okay, let's just go through it step by step. If we click a pawn, okay, the previous selected index, okay, let me just think this through. So if we click a pawn, the previous selected index could probably be the invalid number, no selection. -1 equals no selection. And the currently selected index, which is the same here. If we clicked upon, or rather a chest tile and our previous selected index is larger than 0 and less than, or rather, now let's just do a number of board tiles. We must have clicked previously we would have clicked a chess piece and then we selected a what do you call it? What do you call it? Tile, and then we would want some move logic. Let's see. Move the pawn, please. Okay. So if we click here, we can see that we just select the chess tiles. But if we click the pawn, we click the unit and then move the pawn, please. Triggers. But yeah, we're back to the reset states and yeah, okay. Okay, let's disable this. And let's calculate the unsigned int x. Let's see. And get the remainder, I think, unsigned y. At okay, let's try this. 0, 0. And let's compare. I think this is incorrect. I need to swap them, I think. Let's see, game state, tiles. Why? Let's see. I think. Yeah, they're swapped. Yeah, that makes sense because when you want the column itself, you just want to find the remainder for each row. But to calculate the row number, maybe you just want to do that. Let's see. 0, 0, 0, 1, 1, 1, 5. Yeah, you don't need to grab the remainder. It will be 0 no matter what. Yeah. Okay. Okay. And then we want something like updating the and update the Y as well. And then, of course, update the, let's see, unsigned int at. Let's just do I. Okay, so let's try that. Okay. Oh, wait a minute. Yeah, there we go. And we can actually move our, and then we would like, and this would have to be called, lastly, update the debug thing, because we actually want to overwrite hello buddy, how you doing? And we want to set the int temp index here, and then set the let's see. Yeah, so when we click to move the pawn, no, I haven't. But it's just some basic cube mapping, I think. Okay, so when we click the thingy, we would actually want the previous index to be set to our index here, and then selected index to our previous one, because then we will keep on selecting the pawn. As you can see here, we can keep on clicking. It doesn't deselect. Yeah, and if we click somewhere else, we will deselect. Also, if we click it again, okay, that's pretty interesting. So if we click, yeah, and let's see, previous index, unlike index. So now we can't deselect it by clicking, but we would want to check if uh, if our previous selected index equals our selected index. We want our selected index to be invalidated here. So now we can click the pawn and declick it. Yeah, that feels pretty good. So that basically gives us some. Oh, whoops. There's a bug right there. Now we're what on earth are we doing? Uh, Now we're moving the chess pieces. So let's just try that out again to see if I can. Okay, so whenever I select that one, I actually move the tile itself. Maybe it's during object creation, I think. Poll index. Yeah. So when I create the object, I create the mesh. Okay. Yeah, okay. So I need to set this as well. That's why. Yeah, it was probably set to 0. Yeah, yeah. Everything works. Okay. And we don't want this. And we don't need the reset logic since they're inside the scope up. Okay. Let's remove this. Let's see. Um, uh, let's see. Are there any fast functions? Let's see, so temp, let's see, does it work? No, probably not. No. Okay, we need to create the buffer. Label player. And what is the... Well, oh, it simply passes them. Okay, okay. Let's see. So this should work, right? Yeah. Whoops. Whoops, not S, of course. U. Play one, yeah. Okay. I need to get used to the ImGUI thingy. And let's do a let's do a ImGUI text here. Selected unit. I did a project restart when I did the chess game series. I still have the other project with my own UI. Yeah, I had a long break, so I needed to get back into actually doing some stuff, and creating your own UI is really, really cumbersome. So I decided to use ImGUI for this project here. And in a few episodes, we already are at a stage where we can do some game logic and so forth. So Okay, so let's see. Let's try to see here if we selected the. We can simply copy our. Is larger than or equal to 0, and if it's less than this, we have a selected tile. Oh, thank you very much. That's very nice of you. Uh, but yeah, definitely you learn a lot more by just trying to do stuff. Maybe build some projects just for fun. Oh, I remember you've done a lot of projects, but yeah. Building things from scratch definitely helps. So if we have a tile selected, we will do that. If it's larger than, let's do a selected unit. We could save some time by doing a unsigned int number of tiles here. Actually, we could do that as a thing right here, so we don't redo it. Okay. Selected unit 0, selected unit 1, selected tile 43, and we could do something like uh, and pass in the arguments of wait a minute, this is not where we want it. Game state tile X and game state tile. There we go. So if we select it, we get the X and Y as well. Next turn, next turn. Okay. Great stuff. I think overall they are kind of like split in terms of I started over with a whole new project for this thing. I copied some of the old code, so some of it is ported. I did some of it off stream, but yeah, I think you could do yeah, most of this project here uh, as a separate thing. But it's not really a tutorial per se, it's more like a streaming series. Um, but if you're able to render using the information from the other streams, you would definitely know how to implement most of the stuff that is being done in this separate part with in terms of the whole chest thingy. Okay, so now we can move the pawn. We can actually see which units we have selected. We have some overall game controls and debug information. Uh, okay, let's not put out that anymore. We could do something like moved unit index. No, I haven't implemented something like that. I think that would require a lot of custom work in terms of creating an importer. And I don't know, if you wanted to do something like that, you would probably just use an FBX library of sorts, since writing an entire FBX parser is probably very, very, very cumbersome. But I don't have plans of implementing something like an importer from Blender. I would rather just create an editor where you can edit. All right, yeah, you could always post it on a channel, but or rather the Discord server. But yeah, I'm pretty sure I won't be using it. But thanks. And let's see. Before we update the information, we pass it out. To okay, now our console will output Yeah, great stuff. Okay. So uh, so we basically coded a small movement system. Um, right now, this will be one monolithic scope. Um, for now at least, until we get some more game logic. Movement checking. Mouse-based movement. Whoops. Debug selection. Okay. What should we do next? Since we can do movement, we can always do checking in terms of if we're allowed to move the chess piece in terms of some specific rule sets. Okay. Okay. So I think we should, in order to progress into something that is like a chess kind of game, we should have some kind of like rule system, or rather um, underlying movement rules and unit type, which has a underlying set of movement rules. Also, I think I want to reset this so uh, let's see. Okay, let's try and see. Okay. Let's just move it so that okay, we need to subtract one. I mean, set it up as a chessboard here. And let's move our camera. Okay. Whoops. I misdid that one. There we go. Okay. And do we like the positioning? Well, could probably add a bit more height to this. Uh, 20, maybe 3.5. That's a bit too much, I think. That's way better. And let's see. Let's do something like whenever the camera controller initializes. Let's hard code it into the camera controller. Okay. Okay, let's see if this camera position here is better. Not entirely. That's a bit much. Okay. Um, do we support rotations, or should I just rotate the? We don't care too much. Okay. So what we want to do is create a system where we can um, combine these two parts here. We want a unit type system where we can have certain movement rules, and then we would like some visual information in terms of how uh, do these rules apply for the specified unit. So for instance, if I click this unit here, let's see, I should be able to see the allowed movements in terms of this unit here. Um, in terms of getting highlights on the chessboard. So that means that the material should be temporarily updated in terms of the rendering information. Um, so if this was a regular pawn, these two tiles here should light up a screen so that the player would know that we are allowed to move this pawn here. Like that. Yeah. Basically, what needs to happen is for each of these we could create some kind of like overlay system which controls the highlight. Maybe it's just the tile state. So this is the selection. And let's see if it's dirty. Let's see, create mesh. No, that's not it. Create drawable mesh. That's not it either. Draw debug. Let's see, so draw debug. So we update the whole thing. We simply copy our material for each frame here. So this would mean that if we simply updated an entire set of um, tiles, materials here, yeah, let's see, these are red and blue. Yeah, so if our renderer front end here had a function update mesh transform, select mesh, yeah, this select mesh call could actually be skipped. Oh well, it only gets called if we click something, right? We could also skip it if the previous selection, like -1, and the selected index, like -1. So we only call this if we actually have some updated information. Now it doesn't work right. No. Yeah, we only do it when we click, so we don't really care about performance in terms of that method call. We could do some elaborate logic, but it's probably not worth it. Okay, so our renderer front end here should be able to uh, uh, do something like static void update mesh materials. And let's do a unsigned int pointer materials and a unsigned int count. Unsigned int pointer indices. So I imagine something like passing in the indices and passing in the materials and simply updating them. And let's create something like a for loop here. I++. Indices I material equals materials I and we set it to dirty. Great stuff. And let's try doing a call. So if we click something, if we clicked upon, let's try updating the whole let's do some stuff here just for now. We will and then whoops, there we go. Okay. So in theory, we should be able to do something like this. But nothing happens. Wait a minute. This probably won't work, but let's see. Yeah, as you can see here, that now updates. For some reason, that doesn't update at all. Well, for some reason, that one doesn't work. Huh. Let's see. Drawable meshes, 0, 1, 0. Oh, yeah, it's probably out of bounds. Yeah. Or what? Let's just think about it for a minute. So the kind of like array is filled out like that. when I upload it. Oh, wait a minute, it just overwrites whatever. Yeah, okay. It's because the indices, of course, never update if we do something like. Yeah. Okay, so it's just because our indices are not. Mm, let's see. Okay, we could just use the standard library function. Let's see, not numbers, I think. Numeric. Yeah, basically, you would want actually something like a vector here, because tile indices. Maybe let's do a stdio. Nah, we can't do that. Let's see. Tile indices begin. Tile indices end. 0. Whoops, this is not. And of course, there we go. Here we go. Okay, so we fill out our material buffer here. Okay, and immediately we have some kind of weird effect, but it was, of course, intended. Okay, so we update our entire chessboard right now, and we want something like a original tile set, and we want a highlight tile set. Yeah, I can imagine, and welcome to the stream/channel, by the way. It's pretty fun. Okay, so whenever we create our tile set here, we could do something like tile set because the last one is the material. No, the material. Yeah, the last parameter is the material. So let's store our tile material. I think depth is better. Whoops. And our material. Whoops. This is inside the tile itself. Material. And we process our material here. There we go. This should still work. Now we have the original tile set material stored. So we could do a check here. And let's do a vector. We will do a small heap allocation here, preferably if you wanted to optimize on in terms of performance. Well, it would be known by compile time. Well, huh. Okay, maybe we don't need this. Yeah, for now we will do it like that. We could always optimize on this, but I mean, this allows us to modify whether we want to actually uh, modify specific indices. Yeah. Yeah. Okay, we will keep it like this. Tile materials number, even though it's a heap allocation. Yeah, we might change it. Okay, so we create the materials, and this should set everything to white. Yeah, it does. Okay. Hello. I've been doing programming on and off for a while, uh, but I have no real estimate of how long I've been programming. If it were to be something like in terms of work experience or whatever, since I'm only a hobby programmer. Before I started this channel, I had been doing maybe C++ programming for half a year or something, but it's only part-time anyway. Okay, let me just change the music up a bit. Okay, we could do something like a mem copy here. Where we pick our tile materials, data set, and our game state tiles. Oh, wait a minute, they aren't arranged. Okay. Uh, okay, let's just instead do something like um, tile. Let's just do number of board tiles. I++, and then set our tile materials I to our game state tiles. Oh, okay. Well, I, I guess some of the honestly, if you want the most long-term long-term what do you call it? Long-term reliable learning experience, I think you should uh, not focus on game programming, but start to learn C um, as a foundation for programming and build small applications and programs in C. And then whenever you feel like you are good at the basics of uh, programming in C and you have a basic understanding on how C translates into how a computer works, then you could transition into C++ and do game programming. It will be easy for you when you are able to do C to learn C++ since you can basically write a lot of C in C++ already. So yeah, I would do something like that. If I had to start over, I'd definitely start with C because it teaches you how a computer works in terms of understanding memory and allocations and deallocations and yeah, everything like that. If you just want to fill around and not really be serious about anything, you could start with something like Python or maybe I don't know a lot about it, but maybe JavaScript is pretty okay as well. Yeah. The only problem with C is that it's pretty verbose, but it's because you're pretty close to the hardware all of the time. C is a very low language a low level language, so you have to do a lot of typing, but yeah. If you don't understand the CPU and how memory works, you can't do C. So, and that's way better to get an understanding of that than starting out with a garbage collected programming language that is all object oriented, but because you wouldn't know why something wouldn't work on the lower level and you wouldn't know how to performance optimize in terms of game programming, which is fine if you just want to do some basic game programming and don't really care about performance. But yeah, so there are several options depending on what you want to do, I guess. I just started out with C++ and I didn't know where to start. I don't know. I haven't tried it myself, but maybe brilliant.org has some pretty good stuff about programming and computer science. I don't know, but you could check that out. Okay, so this should um, do nothing. Yeah, right now nothing happens, but what if we increase the material by one? Yeah. So that's pretty cool. So we now have the original state of the board state stored in memory. So whenever I want to like deselect something, I can always revert back to the entire the original state here. store the original state, material state of the chessboard. Create a array, an array of tiles that can be modified according to our chessboard size. Okay, this this is basically a reset version. So yeah, this reverts whatever we do back into the original color. Okay, so if we deselect, we want to call this version here. If we do select a pawn here, and we aren't asking the game to deselect a pawn, we want to do an update here. So let's basically copy this, but we could, for instance, do something like this just for testing. So if we select, okay, our board highlights. Okay, yeah, of course, whenever I reset, yeah, I actually need else. Yeah, handle whenever deselection. Yeah. We could do something like else if. No, let's just do like this. Okay. So if I doesn't work because I didn't get the reset version here. So yeah. So whenever I deselect, great stuff. Okay. Then we would want something like a way to calculate we want a way to calculate whatever tile index we have underlying our pawn here. So And let's try just calculating that. So let's grab our game state, pawn units, right? Units pawn index. Yeah, I don't think it should be called pawn index, unit index. Okay, unit index. Uh, um, Not this one, but tile columns. Let's see. Start index. Um, y times. Okay, let's calculate the start index here and just pass it out to the console. Or, nah. Um, uh, num tiles. Okay. And let's just do some kind of like logic here. Let's see. There we go. Let's try doing that. I'm sorry, I didn't see your message. I'm sorry. The amount of code? Yeah, I think everyone feels like that in the beginning. Let's see. Okay, let's just pass it out to the console. But this is a fairly large program with several lines of code, 1,000 lines of code. So I could imagine it's uh, overwhelming, especially. Yeah, eventually we will do um, homebrew rules, but since okay, this is super wrong. Uh, since I'm building most of the things in terms of the actual game engine from scratch, we will start out by doing something like a real chess game, but eventually we will move into more fun systems and experiment with game design. Uh, Okay, so okay, this should not be multiplied. Let's see, 204. Oh yeah, that sounds fun. Like some kind of mind controlling chess piece, right? Yeah, something definitely happens now. The calculation is still way off. Okay, so this should basically have the x component. Let's see, is it the way that it's laid out in memory? Maybe. Okay, so the game state thingy here, tiles. The first part of it. Okay, the first component for the first eight entries are the x component. So for each row, well, am I not supposed to? Let's just pass it out so I can see why. Uh, X. So let's just see. 11. So maybe we want to subtract the x, or is this problematic? Let's see. So if we do something like the y is always the game state times the tile rows minus, let's try this, the x. Close but no cigar. Okay. So this would be +1, right? +1 times. Okay. So let's see if we move it. Yeah, it doesn't work. This should highlight the corner of the chessboard. Well, it doesn't. -1. Now the corner here highlights minus x+1. Yeah, now it doesn't work. Let me just use a bit of paint here. So I have a grid here. Which is sliced in memory. Oh, wait a minute. This, well, isn't that exactly what we did before? Anyway. Yeah, okay, this is better. Yeah, now it follows. Yeah, and of course we need to reset that as well. Okay. Oh, this only happens whenever we want. And this should be a combination of a reset plus a updated tile. Okay, so this should be the reset version. Yeah, this is actually a modified version then. And we set the tile materials start index here. equals to 2. Okay, so now it should follow along. Yeah. Yeah. I should refactor some of this stuff in terms of we're reusing code segments all over the place. Yeah, and the logic is kind of like hard to follow. Yeah, but at least it works for now. So right now, we simply, yeah, we want something like a um, system that kind of like draws out a set of available tiles. This is kind of like proof of concept that we can select. Oh, yeah, okay, there's a bug as well. Okay, so whenever I select another pawn, yeah, this should actually also create some kind of reset. Yeah, it should basically mimic this. So we start to see that the common functionality is that we initialize a entire board, and we update the entire board every time we click, or rather highlight anything, and we reset whatever we uh, don't want. So yeah, which means that we should probably where's the error? Where's the error? Did I miss a semicolon? Oh, there we go. Yeah. So what started out as a function that seems specific actually gets more generalized. So we could do something like create a series of tiles uh, um, and index them accordingly. Copy the basic um, material state for each tile and potentially modify whatever whatever exceptions to the rule there is. For instance, we could do yeah, this won't work because it will overflow whenever the chess pieces are in let's see, 3. Whenever the chess pieces are in the corners, for instance. So if I move it here, it will actually overflow and could potentially change the mesh indices. Yeah, but whatever. we do have some kind of functionality that should be refactored into separate functions. So to do me create methods to reset an array of tiles and their materials. And add exceptions to that rule. So we could do something like an overall method that maybe it should take params for update method, tile highlight method that's less ambiguous. Board size, number of tiles, original materials, array, or just pointer to the tile information. Yeah, I think we should change this because this is probably fine as a temporary array of sorts. Maybe we don't even care about that. Yeah, maybe we don't need to do it. Maybe we just need the original tile information. Okay. So we could structure something around tile information, materials, original materials. And then we would like to create a array of highlight materials and their indices, and or maybe calculate them. Yeah, we could do a method for that. The tile index of the unit origin, the rules, maybe not the rule set. Maybe we don't want this. So basically it would be something like point to this array here, and this should actually be a vector. Change to vector, eventually to support dynamic allocations, add initialization. Okay. Anyway, So our method, if it took a vector, we wouldn't really care about the size since we could always just fetch it. That is probably more C style. Okay. So, okay, let's just change this. And let's do resize. And most things should work as before. Yeah, except we have a dynamic array instead. Okay. Okay, so we don't need this. We simply need a, let's just do a method here. Void. No. Let's see, tiles. Let's do a vector creation here. Okay, we grab the total size here. Okay, it won't be long before I do a break. We've been going at it for a couple of hours, and I would like to get something to eat and maybe hang around in the sun for a while. Okay, so basically, maybe we want a different version of this. Let's do a unsigned int materials cont unsigned int start. Let's do something like start. Let's see. Well, it should mirror, right? Yeah, it doesn't make sense to do this. Okay. Okay, this will allow us to create specific, or rather update a specific portion of the meshes. It would probably be all of them, but we wouldn't have to specify indices. We could simply just create the array of updated materials and pass that along. So uh, results. Okay, we simply copy the original material, and then we do whatever modifications. Create, reset, original tile set. So this should basically be Pass in the reference to the tile set. 0. Data. Let's see, renderer, materials, start count. Oh, wait a minute. This is because if I do a cast, does it know what I mean? Yeah, it knows now what I mean. Okay, so that's the reset version here. And we can basically skip this. Okay. And let's do something like a std vector unsigned int create a highlight tile set. Oh, this needs to be inside the namespace here, of course. Tiles. Create original tile set. Tiles. Return results. Okay. So we create the original tile set, and then we want a list of vector unsigned int indices. And then a materials. And then we want to iterate over all of these. Um, and we want to set that to our materials at I. And we simply modify the original tile set. You could argue that you could create a tile set with a series of ifs, but I think the overall um, sequential copies are faster than uh, asking the processor to kind of like interleave with if checks, especially when the tile set is fairly small. Maybe if we had thousands of um, thingies. Well, we're only updating a select series of tiles. If we were to update the entire chessboard with new materials each time we clicked, maybe it would be faster just to create um, a complete tile set from scratch instead of overwriting the original tile set. But yeah, right now it won't do much difference. Okay. Okay, so the method create highlighted tile set. And then a specific list of materials that we want to update. Okay. So let's start out with the first time that we actually do this. We do end up in that situation right here. Let's see. Tiles. Let's see. This probably doesn't work. No. Okay, so if okay, Okay, let's change this. So let's see. Let's create something like tile highlights, tile highlight indices, tile highlight materials. Whoops. Okay. Yeah. Okay. Now we can create some logic here where we couple the maybe we would want a struct instead too. Well, yeah. Maybe combine into one struct. Same. So we could simply just um, yeah. Let's just do something like that. There we go. Highlight tile, temp tile here. Tile highlights, that pushback, temp tile here. Tile highlights, there we go. Okay, so this basically allows us to redo the other parts. Let's see, did this work then? No, not yet. Hello, welcome. Let me see. Yeah, so somewhere along the lines, we've made a mistake. If we click on something else, maybe. Well, the underlying array shouldn't change. Oh, wait a minute. I see the statement, the mistake here. It's because I update the underlying There we go. That's the mistake. I modified the original. There we go. Everything works again. Okay. So we refactored a bit. We're now able to create a series of highlighted tiles that we pass along into our method, and then everything is also a bit more readable. Let's just put this into something like this. Highlight unit movement. Um, reset selection, and therefore board highlights. Whoops. And then we of course highlight unit movement. Deselection. Clicked on something else than board or units. Okay. Great stuff. So for instance, if we wanted to create a series of maybe we wanted something like, okay, let's do it in terms of the red material here. Maybe we should do an enum eventually for that. But we could do something like temp tile index equals start index minus and set that to blue, and then push this. Yeah. So as you can see, we simply add stuff. Right now it won't work because it's out of range. We could use something like player Just for instance here. There we go. Whoops. What happened? Okay. Let me just, before I end the stream here, this is gray. A base white-ish. Red material. Blue material. And then let's create a green highlight material. Let's just change the material properties here. So that's 0, 1, 2, 3, 4. Okay. Great stuff. I think that will be it for this part of the stream. Maybe I'll get back to it later on, but I think we got a good amount of progress done for this stream. We now have highlighting of the chessboard, so that's pretty great. Yeah. In the next episode, we should do something like, yeah, thank you. What have you been working on? In the next episode, I'll create a series of rule sets for the unit movement. Yeah. Are you using Linux or just Windows or? But yeah, we will create a rule set for the pawns here and make sure that the game actually deducts the kind of like boundaries for the whole highlighting. Let's see. So we want something like we did that, but we need to create a method for highlight. Yeah, okay. Highlight calculations with bounce checking in terms of the tile set. For and use the rule unit movement rules. Okay. How much on the X, Y, C? Oh no, not C. Are the unit allowed to move? Maybe just maybe eventually to do special move sets. All right, so that's the focus for the next episode, so that we can do some actual bounce checking in terms of the highlighting, and also maybe in terms of enforcing the rule set. Yeah, but yeah, I'll do a break, and maybe I'll get back to streaming today. Maybe I'll do some of it tomorrow. We'll have to see. But yeah. Thanks to everyone who dropped by, visited the stream, and made things more interactive. It's always a pleasure. Feel free to check out the Discord server in the description down below. Um, and hopefully I'll be seeing you guys soon. All right, sleep tight, man. Take care, everyone. Bye bye.